I welcome everyone to today's webinar titled Case Studies for Challenging Fire Detection. I will take you on a journey to successfully design fire protection with special fire detection technologies. In detail, I will present you a useful tool to help you select the right detection technology for a specific set of challenges. After finding this suitable special fire detection technology, we will soon find out that challenging environments require performance-based design. We will then see if the allegation that performance-based design is difficult and complex really is true. Finally, for the core part of the webinar, where I will show you in detail how our growing verticals library of guides delivers the design support you need. But first, a brief introduction about myself. I started out as a hard and software development engineer before I went into project management, where I managed software development projects. After coming back to the Swiss Securitas Group a second time, I worked in consulting and corporate development. In 2018, I joined the Sales International team at Securiton as a Director of Vertical Application Management, or short VAM, where we mainly produce our guides for our verticals library. Please feel free to connect with me over LinkedIn. I have posted you the QR code, should be easy enough. Thank you. Now, selecting the right fire detection technology or the right type of fire detection, or last but not least, the right product is not an easy task. We all feel pretty safe designing standard fire detection. We have experience, we have lots of examples to prove it works, and the codes, standards, codes of practice, etc. are numerous and easily available. However, as soon as we encounter a situation with a particular challenge or even a set of challenges, it may not be so easy and straightforward anymore. And sometimes it is hard to know what to do. Let me start our journey by making a couple of examples of what I mean with some challenges require special fire detection. Challenges like large open spaces and stratification, or obstruction, if you need access for maintenance, if you have a high airflow in the area you monitor, smoke dilutes. In cases like this, you would opt for special fire detection based on aspirating smoke detection. If you have extreme temperatures, polluted air, or an otherwise aggressive environment, you may opt to our linear type heat detectors. But of course, the challenges are numerous, and special fire detection is not limited to those two products. Therefore, I would like to introduce our Fire Detector Guide, a tool you can use for free, a tool that helps you selecting the right technology and the right product to overcome particular challenges. And this is how it works. You open a web browser, you surf to our homepage, securiton.com, where at the bottom of the page, you will find the Fire Detector Guide. If you start the Fire Detector Guide for the first time, you will need to register. It's a simple, straightforward process. From that moment on, once you register, you can log in and it takes you directly to the Fire Detector Guide. The Fire Detector Guide lists all our products available at any given moment of time. It includes special fire detection, but also standard fire detection products. On the top, we have two divisions. One for the sensing element, where we can select criteria challenges, for example, high air velocity in combination with inaccessible access. And the list is then reduced to the best fire detection type to suit or to address that challenge. The list is in a ranking, so the topmost product in the list is best suited for any given set of challenges. And we provide you information about the product with some notes here. The evaluation unit must remain accessible. Of course, it's mounted outside the monitored area. You can have a different set of criteria for the sensing element. For example, when we go into hazardous areas or X zones, as people call them, we are reduced to 5 types of fire detection, including flame detectors. If we add a high EMC load, the list is further reduced to our linear type heat detectors, for example. Again, you have a ranking, and here we have a special note that the evaluation unit is not suited for X zones, so it must be mounted outside the hazardous area. You can select challenges for both the sensing element, but also for the evaluation unit, which may sometimes be mounted outside the monitored area. For example, if we have hygienic requirements, we are down to 14 possible fire detection solutions, again with a ranking and information to it. If we pair that with a high ambient temperature of, let's say, 70 degrees centigrade, we are down to ADW basically our linear type heat detectors, again with a ranking and additional information. A very useful tool. Check it out. It's free. It's on our website, and it will really help you. Now that we have identified a particular challenge and we found a suitable special fire detection solution to deal with these challenges, okay, but alas, we can't find much to help us in codes and standards. Therefore, we have to apply a performance-based design approach to release the full potential of our special fire solution. Special fire detection solution. But what is performance-based design? Performance-based design, as a definition by E.J. Gibson made already in 1982, states that first and foremost, the performance approach is the practice of thinking and working in terms of ends rather than means. It is concerned with what a building or a building product is required to do, and not with prescribing how it is to be constructed. Performance-based design approaches consider the ultimate goal and establish objectives and performance criteria that would result in achieving that ultimate goal. These goals then must be agreed upon by all project stakeholders. That includes the authorities having jurisdiction, the owners, the design team, the end user, the insurance companies, etc. But what does the code say about special fire detection? Not much, you might say. Here are, for example, citation of the complete coverage of performance-based design in the NFPA 72. 3 paragraphs that state what is required to document the proposed solution, allowing the authority of having jurisdiction to determine that the design we make meets the performance objectives we defined, and finally, that you can only make changes to the design or the solution after the authority having jurisdiction has approved them. Having seen how performance-based design is defined and how codes deal with it, as well as what we have experienced in doing with standard fire detection before and what the customer expects from us, we might conclude that performance-based design is difficult and complex. However, I say performance-based design is not difficult and it is not complex, but we must persuade the customer and get approval by the authorities having jurisdiction. The process to do that is quite simple and straightforward. We need a risk-based approach where we identify the risk and define the performance goals. A risk analysis is a widely documented process. You can get loads and loads of information documentation on the internet about a risk analysis and a risk-based approach. Once we have defined our performance goals, I say it again, they must be agreed upon by all the stakeholders. Other than that, you can't go on. You must overcome that hurdle to have the agreement of all stakeholders in the project. Finally, once we have a design on performance goals, once we have defined the performance goals, we need them to be approved by the authority having jurisdiction. On our journey, we now have identified challenges. We have presented a tool to find out what suitable special fire detection there is to address them. And we have defined the performance goals. Now, how exactly are we designing and how can case studies help us with that? Let me start with explaining our verticals library. Our verticals library really is your library. It today features more than 20 design guides and case studies. Where we say a design guide usually covers a whole industry, such as warehousing and logistics, or clean rooms and otherwise controlled environments, or transport hubs, mass rapid transport hubs. Whereas a case study is a bit more focused on a particular application. For example, belt conveying systems or recycling plants or animal sheds. Our guides, as we collectively call them, cover a wide range of industries applications. They illustrate how design for special fire detection can be done and how it has been done. They can all be found on securiton.com, our homepage, and I will provide you with an easy-to-use QR code a little bit later. Now, before we dive into an example of a recently published guide, I would like to ask Zach, do we have any questions already?
We have a question, Markus, and the first one is, I had not seen your fire detection guide before, even though I normally follow Securiton. Do I need special access?
Yes, yes, you're right. We haven't been actively communicating about that in the past. That is, we could have done more probably. But as I said, it's on the website, and it's very easy to use. You register once, fill in the form, and from that moment on, you have access. You can log in, and we update the tool on a frequent basis.
All right, thank you very much. We don't have any questions further, so please go ahead. Thank you.
Okay, thank you. So yes, I mentioned we have a collection of more than 20 guides in your verticals library. Let's look a little closer at one of more recent ones that we published, and that one covers intrinsically safe and hazardous areas, or X zones, as some people call it. Let me show you how our guides help you to successfully design a special fire detection solution based on a performance-based design approach. Our guides are all structured in a similar way. Let's have a closer look at the table of contents, and in particular at the aspects of fire safety and prevention first. The aspects of fire safety and prevention, again, are targeted to this particular application. So we speak of application-specific hazards, or in the case here, of hazards that occur in an intrinsically safe and hazardous area. We cover the, again, application-specific challenges that we face here, and we touch on the application-specific risk and risk design and performance-based design. In more detail, it features tables. Here, for example, again, in an X zone application, it explains the difference between the relevant standards. For example, the North American class 1, 2, 3 to distinguish hazards, whereas the Europeans go on zone 0, zone 20, and 21 and 22 to identify the different hazards that occur. A case study also features large graphics and illustrations here explaining the particularities of standards. In this case here, we explain graphically the zone concept that we find according to the European standards. It features images supporting the text of the guide. Here, as an example, fibers and flyings is a class 3 hazard according to the North American standard, and it obviously occurs in cotton mills and areas like that. But we also go beyond. We go into explaining what higher hazards can occur in an otherwise standard occupancy. Think of a university campus which you would protect with standard fire detection largely, but maybe on this university campus somewhere there is a chemistry lab that operates and stores flammable liquids and gases and stuff like that. So for this area of higher hazard, you need an adequate fire protection design based on special fire detection. Further, we emphasize early warning fire detection. Early warning fire detection has a very positive impact. It, on one side, enlarges the time for people to leave the hazardous area or the area in general before the fire gets out of hand. It enlarges that time significantly, and on the other side, it reduces business interruption damage because we detect the fires early, ideally before, much longer before they go out of hands. And last but not least, we cover the particular challenges of an application and what of our products are best suited to tackle these and why they are best suited to tackle these. This helps you convincing the stakeholders that you have around the table when you present your performance-based design. It explains you why you select a particular product and what the benefits are of selecting that particular product. If we then go back to the table of contents and focus on chapter 3, this is now where, if you remember the fire detector guide I showed you at the beginning, this here is the core chapter of the guide where we explain how to design fire protection solutions with the product most suitable, if found it in the fire detector guide, to overcome these challenges. But again, we also go beyond that into risk and performance-based design. So we are in this chapter introducing the detection product portfolio that is suitable to overcome the challenges of, again, this particular application. Here, as we speak of a hazardous area, the range of possible products is rather wide. We have case studies that focus entirely on ASD, or case studies that focus entirely on linear type heat detection with our Listec D-List cable. Here, in this case, we have smoke aspirating systems, linear type heat detectors, but also beam detectors that are suitable. We, for each of these suitable products, we introduce key performance parameters. For example, such as how long tubes can be for an ASD. We then make a comparison between major codes and standards that are applicable, again, to a specific industry or application. And we compare them in terms of detector spacing, sensitivity, transport time, etc. on for the example of a smoke aspirating system. We then cover general open space detection that is mainly designed for prescriptive code requirements, where it says how big the maximum monitored area can be by a sampling hole, giving a certain number of air exchanges per hour. And we give recommendations. At this point, we give recommendations for performance-based early warning detection design. For example, by enlarging the number of sampling holes, or by increasing the sensitivity of the detector as such to make use of the pre-alarm levels that we have built in, again, for example, in the ASD. But we go beyond. We go to supplementary detection for these high-risk objects. You remember the chemistry lab I was mentioning on the campus. So we make design recommendations for such objects or any objects with higher risk on a performance-based design approach, which I remind you has the benefits that it both enlarges life safety egress time and it reduces business interruption and fire damage. We also focus on dust and exhaust detection with ASD, designing for prescriptive requirements basic on the basis of NFPA 72 when it comes to the spacing, the placement, the orientation of sampling holes, but also how far away the pipe should be installed from the next bend of the duct, and so on and so forth for ducts and exhaust grills. If we look at linear heat detection, we have also object protection within the hazardous area. Again, it's pretty much the same thing as for ASD. We just show you how to apply a different detection technology in these things, how to install it, and what you must pay attention to. And we go beyond with here as an example, outdoor detection with an ADW for transformers. The protection of transformers is not standardized. There's no code, so we give you recommendations for the installation, for example, of the sensing coils. Now, this here, for example, is an outdoor application. Imagine you have a cloud covering the sun, and this cloud moves on, and the sun, bang, comes back and shines on the transformer. That will create a massive increase of temperature in a very short time. Therefore, we tested that, and we make the recommendation that you cover the sensing coil so that the sunlight doesn't get to it directly. So we make this sort of recommendations as well in our guides. That is the core chapter of the guide, but we have additional chapters to round it off. We offer you a 360-degree view on fire protection that says we explain how you can integrate these systems with our own fire alarm control panels, with building management systems, with alarm management systems and such. We offer you design support, and we, last but not least, offer you an extensive list of references, additional literature, and we touch on more detail in the appendices of guide. The time in this webinar will be a bit too short to dive into or to drill down into all of these, but I would like to highlight our design support tools and the services we provide with it, because again, that's where we can really help you create or realizing a performance-based design approach. We have sophisticated software design tools, both for ASD and ADW. They allow you, once you've designed the network, the sensor network, they allow you to verify the conformity of the design to a selected sensitivity class, for example, or to a selected response class for linear type heat detectors. In addition, they also produce a bill of material, which you quite easily can convert into a request for quotation. We also have commissioning tools that allow you the setting of parameters on the devices over the network, so you don't necessarily need to physically go to the device. If you are uncertain with a design or how to do that exactly, let us help you. We provide application field engineering support, and we operate a design center. So just send us the building plans and project information, and we'll take it from there and provide you with a design, with a bill of material required to realize a project. In addition, we also maintain a worldwide network of partners and we employ local employees. Let me conclude the journey and summarize again how case studies support you when you have a challenging project that requires special fire detection. Our library holds more than 20 guides. Scan the QR code and you get directly to the library. As you have seen, they cover targeted industries and specialist applications, especially for tough fire detection challenges. Performance-based design is important to us because with a performance-based design approach, your fire protection design can reach a whole new level. But of course, we also cover codes and standard-based design. We emphasize very early warning fire detection because we believe in early detection and a consequent response plan, which really saves lives and protects assets. And the best is they are available for free. And if you cannot find what you're looking for, get in touch with me and I will look into it if we can create a guide for a specific application or challenge you face. Thank you very much. That concludes my presentation. Zach, do we have any more questions?
Yes, Marcus, we have a question from one of the attendees, and the question is there any system design available for the shock freezer, high performance freezer, where high air currents lead to massive formation of ice and fogging? There is the restriction of using ASD in the manual for this freezer. So basically, somebody's asking if there's a design guide for blast freezers or shock freezers, or are we having a plan to come up with a design guide?
Blast and shock freezers, but not with ASD, with another detection technology, if I understand correctly.
All right. Thank you very much.
I'm sorry to say no. At the moment we don't have a guide that covers this. We would need to look into how to if ASD is not suitable or is for any other reason not applicable. We would have to go to linear heat, possibly with ADW, since this has a pretty fast response time. We would have to look into it. Of course, with heat detection, it becomes difficult in a shock freezer because it will take time to build heat when you shock freeze. You see what I mean? When you have a high airflow in a shock freezer way below zero temperatures, the fire would need to be fairly large to be detected. So that possibly might require even testing.
Thank you. The next question is it possible to get access to case studies and guides without a login?
Sadly, no. You have to download the guides. You have to register once, and then you can log in. When you register, you leave your email address, which then helps me to get in touch with you and invite you for webinars such as this, for example. So that is sort of, you get the guides for free, but in return I ask for your contact details.
The next question is, what do I do if I can't find a guide for the application area I need?
As I just mentioned, concluding my presentation, get in touch with me and I look into it. It's as simple as that.
Thank you. The next question, Marcus, is you talk about the need for special fire detection in PBD in challenging places. But what about those who just want to use ASD because it's a great option for normal fire detection?
Yes, good question. I recommend you look into our also not too long ago published case study on replacing standard point type smoke detectors with ASD. It's all in there. How to design, what to pay attention to, it's all in there. The guide is available. Replacing point type smoke detectors with ASD is available in the library.
Thank you. The last question I have is, the fire detector guide includes products I don't work with. Is there a way of ensuring it only offers solutions that are possible for me?
No, sadly, I cannot restrict that. So if the fire detector guide provides you with a product which you don't yet have in your lineup, or which you can't get, I suggest you get in touch with our sales guys, and they help you make the product available for you at one end, or that you choose the one of the second best options that the fire detector guide might list, and try with this.
All right, so we've got another question from the attendee, and the question is, do you have any fire engineering simulation, in brackets CFD, study and a real test validation for high buildings over 12 meters?
No, we don't. It's
Okay.
we don't have these tools. We don't have access to these tools. I would have, if this would require me to ask a third party.
So, well, we don't have any further questions. So thank you everybody for attending our webinar. And the next webinar would be engineering solutions for aspiration systems, which will be held in September, and we will send you invitations. So Marcus, thank you very much for having the webinar, and we look forward to seeing you soon again. Bye for now. Bye-bye.
Thank you all, and do not forget to follow us on LinkedIn and Instagram. Thank you. Goodbye.